有限な感じないといかんね。
これをwe restrict from 0 to 1. And if we want to if we want to compute it, we have to know the characteristic function, and we try to derive it. If we derive it, we can know the characteristic function from there. It can so if we have this term, and we have these two terms, we can know the EX and the variance X. We can get the expectation and variance from the derivative of the characteristic function. From this kind of background, we can give a small theory. So if f is in L1 and L2, because f in L1 is like a linear function of p dash lambda, and in the L2 is what we mentioned about is this kind. One norm is less than equal to the two norm. So if f is in the L1 intersection, so then if f is in the space, we can know integral can be in the L2 space. So we will know a little property. It can be a small theory. So when we restrict lambda to Z, so we can know f and in the space, and we can have the expectation and the finite variance. So the expectation will be this, and the variance will be we have the mean and variance. So we have, if we have the collection, so we can both the R1, starting R1. So it's isomorphic to L2, Z, and we can, if we have R1, R1 equal to this collection. So if we have this collection R1, the R1 is the Hilbert space. The R1 is isomorphic to L2 resolute this space. So if we have the middle space, we can introduce the Gilfan triple. So if we have the R1, we can pick to do this kind of triple to make it up. And how do we try to define the norm? The norm R1 can be defined as the normal norm and the derivative function, the norm plus. They can be the R1's norm. So we can know the R1 because if we see the sine n theta and cosine n theta, then we can know the summation n squared or 1 over n squared can be finite because it's the Hilbert-Smith type. So if we have this, we have R1, we have the norm of R1, so we can try to compute a lot of the mean and square, even the 3 times the moment of 3 and the moment greater than 3. We can compute this. And now we have R1, so we want to define the R11. What's the R11? The E1 is nuclear space.
パラメータは01ですね。10秒空間の構造が使えるから。
So we have the R1. So now we try to define R11. And from the nuclear space, and we can get R11 is the R1. So if we have the R11, we can know the R1 minus 1 can be the dual space of R11. So like we just mentioned about why we need this kind of space, because we want to know the P dash lambda will be in this space. So if we know the P dash lambda is in the R1 minus 1 space, so we can consider the polynomial. And first we consider consider the homogeneous polynomial of degree 1. So because the degree 1 is not simple, so we only consider this. And after this, if we can do more investigate about it, we will try to think about the degree is not 1. But now, 1 is very difficult. So we just look the polynomial and it's equal to 1. So if we know this kind of space definition, we can try to compute the p dash lambda. What's the mean and the variance in p dash lambda? If we try to compute it, we can think about this from the probability function. This perceived probability function. So the heading is 1 incidence. And the second order is maybe more complicated to compute. So we have a roughly idea is if we have a delta p over delta p over delta minus 1, the hacking. This can be space. This can be also going on to the RZ. RZ is the constant space, like it. So we have a roughly idea about it. And the second, we know if we try to compute this in the 2 square, we may get to 1 over delta plus et. So if we have this kind of expectation, we can say maybe the minus minus 1 over the lambda minus this, we can get it is orthogonal to RZ and orthogonal to R1. Because we want to think it may be R2. But R2 is roughly thinking. We didn't have give it the R2 the specific definition. So we just have this kind of R2 in mind, but not give a specific definition. So if we subtract some infinity, this kind of be an infinity. So we can to do some kind of renormalize. So we will to next section, section 4. Now we know something in the section 1 is about some property of the polarity functional and independent of this kind of the random variable interval f lambda product p dash lambda p lambda equal. We know some property in section 2, and we have more generalized in the section 3. In section 3, we know the triple R1 and R1, 1 and R1 minus 1 is very important because if we have the P dash lambda in R1 minus 1, we can have to do some compute about P dash lambda, like the renormalized. And before renormalized, we know the disposition of P dash lambda and even the variance of P dash lambda. So because we know the P dash lambda will in this kind of space, so we know we have the norm of R1. We can try to compute these two variables. So next, we will go to the section 4. The section 4 is about the polynomial. In P dash lambda, like we just say, we just can consider about this. Because if n is equal greater than 2 or more, that will be very difficult. So we now just consider about n equal to 1. So this kind of polynomial, we want to consider about it. But we know the renormalized in physics, we have to subtract some infinity item. So it's not simple to renormalize. We will do some less, maybe like S transform to renormalize. But we don't have a significant definition about the P dash lambda now. So I'm still working, try to give a complete definition. So if we know it's about the orthogonal polynomial, so we use the some kind of orthogonal polynomial to do the renormalize. And if we do the renormalize, we want to compute the S handcount of the P dash lambda. But now I just have the roughly idea. So, Mata denbu kenkyū shimasu. So I'm still working on it. So, in section 4, the polynomial in the P dash lambda, we consider about this kind of polynomial. And we want to do the first step to renormalize. So the first step is very important. I just mentioned about the orthogonal polynomial. So we have to pick one kind of orthogonal polynomial to do the renormalize. So finally, we find the Poisson-Charlier polynomial. It can suit for our P dash lambda. So in the Poisson-Charlier polynomial, we know the term will be Pnx lambda. Can be this kind of term. This term, if we try to find the example of P1 x lambda and P2 x lambda, will finally know. Actually, they are orthogonal or orthogonal. So the P1 x lambda will be x minus lambda, and some kind of coefficient. And the second is also have some kind of coefficient, and it will be the actually, we know the two kinds of polynomials, they will be orthogonal to each other, even orthogonal to P0. So P0 will orthogonal to 1 and 2, and P1 will orthogonal to each other. So like this, so we can know the Poisson-Charlier polynomial can play very important role in the P dash lambda renormalized. So we have this kind of idea in our mind, but I still compute a lot of. I'm still working, so not yet to give a complete result. So now, having been the system variable P dash lambda, we can establish a class of a sensible and meaningful function, actually function, follows the standard method in analysis. First, we have to define the most element and basic function. That's the polynomial P dash lambda, this kind. Our ideal is to apply the renormalize to the d lambda. dp lambda is like P dash lambda. So we want to subtract some expectation to have it. As a formal expression, we must have the maybe P dash lambda squared minus 1 d lambda, this kind of renormalized. So we can subtract the infinity. And this kind is like what we compute. So this may be subtract some infinity to renormalize it. And if we have this previous Gilbert triple R1, R11, R1 minus 1, we can know the injection may be the Hilbert's means type. So the n square, 1 over n square will be finite. So if we have this idea in our mind,
今のよくわからないからなんで N 分の1と10が収束するとなんでいいわけですよ。何を言いたかった？
さっき書きました。
リノマリゼーション。リノマリゼーションと今のどういう関係にあるんですか
？Just idea.
それから何ページですか
So we know the space R1 minus 1 will be an infinity dimension. So
仕事一緒にと言いたかった。そうか。
So the significance is P dash lambda. Lambda is restrict to 0 So this will be total in the R1 minus 1. The total means it can, if we spend this, it can be maybe the same space. So we have some theory about it. So we know the secret C